This text is directly from the CAASPP website. It's a sample performance task that students are expected to do on the SBAC. The author wasn't specified here, but I chose this text because I know a lot of students struggle with the math portion of the performance task on the SBAC, so that is why I chose this piece of text. As I look over this piece of text, I notice that there are two pictures of candles. I notice that candle A is much taller than candle B, whereas candle B is wider than candle A is. And then I notice that that is true in the second picture as well. Candle B is wider than candle A, but candle A is taller than candle B. But I do also notice that compared to picture 1, the candles in the second picture seem to be a bit shorter than the original picture. I wonder if that means that maybe these candles are lit and maybe they're melting. So when they're melting, they're getting a little bit shorter. Let's go ahead and read the problem and see if my predictions are correct. So your friend Abby is making a movie. She is filming a fancy dinner scene, and she has 2 types of candles on the table. She wants to determine how long the candles will last. So I'm picturing Abby. She's making a movie, and I picture her on this fancy set of a high production movie. There's cameras, studio lights, and other crew members. She's filming a dinner scene, and she has the 2 types of candles on the table for her dinner scene. I'm assuming she probably has some sort of candle holder underneath them or something to catch that burning wax. Abby wants to determine how long the candles will last. I'm going to go ahead and underline this statement because it seems like it will be important. She wants to determine how long the candles will last. Looking again at the candles, candle B actually reminds me of a Bath and Body Works candle that I own, nice and round and short. And then candle A reminds me a little bit more of the candle from Beauty and the Beast, more tall and slender. As we continue reading, she takes a picture, lights the candles, and then lets them burn for 1 hour. Cool, so my prediction was correct. She does light these candles. So she takes a picture, she then lights the candles and then lets them burn for 1 hour. She then takes a second picture. You can assume that the candle burns at its own constant rate. Okay, so this box on the left indicates after the first picture because it's right underneath the first picture. And the time equals 0 hours at the bottom of that picture, indicating that no time has passed while this picture has been taken. Whereas in the second picture, you can see directly under it, it says time equals 1 hour. This indicates that the second picture was taken an hour later. You can assume that each candle burns at its own constant rate. Constant rate. I'm going to highlight that. That looks a bit unfamiliar to me. Let me keep reading and see if I can use any context clues to help me define what that constant rate might be, because I'm not sure quite what that is. Candle A, initial height equals 20 centimeters. So candle A initial height equals 20 centimeters. Candle B initial height equals 10 centimeters. Well, I remember initial height from last unit. I know that the initial height, or initial, just means the starting point. So that means that candle A started 20 centimeters high, and candle B started 10 centimeters high. Candle A height after burning for 1 hour equals 16 centimeters. Candle A height after burning for 1 hour equals 16 centimeters. So after 1 hour of being lit, candle A went from 20 centimeters to 16 centimeters. Candle B height after 1 hour, after burning for 1 hour. So after that candle was lit and burning for an hour, candle B went from 10 centimeters to 9 centimeters. I wonder if this can help me figure out what constant rate means. Each candle burns at its own constant rate. That must mean that as the candles burn, they shrink by the same height every time. They burn at the same rate. So for candle A, it started at 20 centimeters and then went down to 16. So the constant rate for candle A would be 4 centimeters. It burned off 4 centimeters. Whereas candle B went from 10 centimeters to 9 centimeters, so that constant rate would be 1 centimeter. It goes down, candle B goes down 1 centimeter every hour. You will use this information to help Abby think about the candles she might use for the film. Okay, so I'm assuming there's going to be questions about the candles and how fast they burn. Going back to the main idea that I underlined up here, she wants to determine how long the candles will last. I might have to figure out how long the candles will last before they completely burn out. But let's go ahead and see.